Welcome back to The Explainer, everyone. I am absolutely thrilled you're joining me today, especially all of you software engineers and system architects out there. Today, we're setting the stage for a complete bottom-up teardown of Google's absolute latest infrastructure and AI capabilities, pulled directly from their most recent announcements. We're going to look at the very foundation of how these massive systems operate. We'll start way down at the bare metal compute level and work our way all the way up through the logic layers right to the end-user application layer. If you want to know what the future of agentic coding and hardware scaling actually looks like, well, you are definitely in the right place.
Okay, let's dive into this. Here is our agenda for today. Number 1, next-gen TPU infrastructure. 2, Gemini 3.5 Flash unveiled. 3, building an OS from scratch. 4, vibe coding in Google Flow. And 5, the AI-powered developer.
Section 1. Next-gen TPU infrastructure. Powering the shift.
3. That is the multiplier here. The new 8th generation TPUs provide nearly 3 times the raw computing power of the previous generation. Look, as engineers, we know that generational leaps in compute are usually pretty incremental, right? But a 3x jump in raw power, that fundamentally changes the math on what kinds of models you can train and how quickly you can iterate. But raw power on a single chip is really only half the story in modern system architecture.
The other half of the story is scale, and that brings us to this absolutely staggering figure, 1 million. Google announced they can now seamlessly distribute training across multiple sites, effectively scaling operations across more than 1 million TPUs globally. Just think about the networking backplane for a second and the distributed systems architecture required to pool 1 million TPUs for large-scale pre-training. It's essentially a massive, unified, global compute engine.
Now, what's really interesting here is the shift from training to runtime, 1500. This represents the lightning-fast inference speed of the new TPU 8i. In a live demonstration where a prompt asked the AI to create a Chrome Dino game, the model output nearly 1500 tokens per second. It was literally so fast that it almost took longer to type out the request than it did for the AI to generate the fully playable game.
So, what does this all mean? Well, the crucial takeaway here is the purposeful architectural split Google has designed. On one hand, you have the heavy lifter, the 8th gen TPUs. These are heavily optimized for the grueling work of large-scale distributed pre-training across those global sites. On the other hand, you have the TPU-II, built deliberately for inference. It's designed strictly for rapid model responses and execution. Basically, this means your training workloads and your production API calls aren't bottlenecking each other anymore. They're running on silicon specifically tailored for their unique demands.
Section 2. Gemini 3.5 Flash unveiled. The logic layer.
Google officially introduced Gemini 3.5 Flash. This is a powerful new model that brings advanced agentic coding capabilities directly to developers today inside a platform called Anti-Gravity. And let me be clear, this isn't just a basic autocomplete or a simple chatbot. Gemini 3.5 Flash acts as a crucial link that introduces true autonomous agentic workflows directly into a software engineer's daily toolkit.
Which naturally leads us to a pretty fascinating question. So what actually happens when you let Gemini 3.5 Flash loose on an initially empty project? No boilerplate, no templates, just absolute zero. Well, the engineering team at Google decided to test exactly that.
Section 3. Building an OS from scratch, anti-gravity at work.
They gave the agent a highly complex task: build a functioning operating system from absolute scratch. And this brilliantly illustrates the sheer scale of what happened next. Over a total build time of just 12 hours, Anti-Gravity deployed 93 subagents working simultaneously in parallel. Together, they made over 15,000 discrete model requests and processed an astonishing 2.6 billion tokens. All of this orchestration happened completely autonomously, just to get an empty repository to the core of a functioning OS. But as any software engineer knows, building an OS is never just a straight line, right? You inevitably hit a wall.
During the build process, they hit a snag. The OS was completely missing necessary video and keyboard drivers. It simply wouldn't function. So what did the system do? Step 1, it detected those missing drivers. Step 2, rather than just stopping and asking a human for help, Anti-Gravity 2.0 did a whole host of independent research to figure out how to solve the problem itself. Step 3, it autonomously wrote over 100 lines of complex driver code. And finally, Step 4, it successfully compiled the functioning operating system. It literally debugged its own creation without any human intervention. And by the way, Anti-Gravity 2.0 is available globally for everyone.
Section 4. Vibe coding in Google Flow, the application layer. We've seen the hardware, we've seen the raw model logic, and we've seen the underlying agent architecture. Now let's look at how these multi-agent capabilities integrate into daily, hands-on creative tooling. Google introduced a concept through this exact quote, "Now you can vibe code any creative tool you could think of right in Flow, custom built by you for your unique creative process." This whole idea of vibe coding empowers engineers and creators to easily build, share, and remix custom internal tools. Whether you want to design specific video effects, generate hand-drawn animations, or layer text, you can just vibe code a custom workflow inside Google Flow that does exactly what you need. It's a real game changer.
Under the hood, Google Flow received a massive technical upgrade to make all this possible. Flow evolved away from just simple, single-prompt execution. Now, your agent can take simultaneous, multiple actions all at once, managing parallel workflows. So, for example, if you feed it an image, the agents will first analyze exactly what is happening in the scene. Then, they'll independently conceptualize the most compelling camera angles for that specific scene. Finally, boom! That single image is instantly converted into 16 unique videos. This isn't just sequential generation anymore, it's a multi-agent system analyzing and executing complex creative decisions in parallel.
Section 5. The AI-powered developer. What comes next?
We've journeyed all the way from the incredible raw computing power of distributed TPUs up through the lightning-fast Gemini 3.5 flash logic layer and right into the agentic workflows of anti-gravity and Google Flow. So I want to leave you with this thought. As software engineers, our day-to-day reality is fundamentally shifting. When autonomous sub-agents can do independent research, write complex hardware drivers, and compile an operating system from scratch in just 12 hours, what will you build with the time you get back? How does your role as a system architect evolve when you're managing agents instead of just writing syntax? It's a wildly fascinating new landscape, and I highly encourage you to dive into these tools and see for yourself. Thanks so much for joining me on this explainer, and I'll catch you on the next one.